3-Eye Atlas is moving closer to the sun. There's still so much we don't know, and we've got some fresh images of 3-Eye Atlas, the third ever interstellar object observed from Earth, currently racing through our solar system.
Far beyond the orbit of Neptune, in a region where the darkness is nearly complete and sunlight dwindles into a pale suggestion, astronomers have detected something that defies every expectation they once held about the frontier of the solar system. A colossal object more than 100 times the size of anything previously tracked in that distant expanse has surged into observation. It is not merely drifting. It is following a trajectory that has brought it into alignment with the peculiar interstellar visitor once named 3-Eye/Atlas, a body whose very discovery rattled the foundations of planetary science. The arrival of this new gargantuan intruder feels like an echo of a greater story, one written on scales far larger than any human eye has seen. Before we start, smash the like and subscribe buttons for more updates. The sheer enormity of the newcomer is staggering. Where asteroids and icy planetoids have long been the quiet tenants of the outer solar system, this new arrival is something else entirely. Its bulk dwarfs the familiar denizens of the Kuiper Belt, those frozen relics of solar system formation. At 100 times the scale of its neighbors, it is as though an ancient leviathan had drifted into a pond filled with minnows. Astronomers studying the object were quick to point out that its apparent size rules out any simple classification. It is not a comet in the ordinary sense, nor a planetesimal as we have cataloged them. Its mass suggests a body whose gravity alone could stir the orbits of nearby fragments, distorting the architecture of a region once thought to be stable. Yet the most unsettling aspect of this discovery lies not in its size, but in its intent. The orbital calculations trace a path not random, not wandering, but disturbingly purposeful. This titanic object is on a course that intersects with 3-Eye/Atlas, the third recorded interstellar interloper to cross into our solar neighborhood. That earlier body, faint and fleeting though it was, stirred intense debate over its origin. Now, with 100 times larger traveler appearing as though summoned by its trail, the implications are nearly impossible to dismiss. It is as if the solar system has been chosen as the stage for a convergence of forces far beyond our making. The targeting of 3-Eye/Atlas is not coincidence, at least not in the way scientists define chance when the odds plummet toward impossibility. Orbital mechanics reveal alignments that should never overlap so perfectly unless bound by a greater order. The vast newcomer carries momentum from a realm uncharted, its velocity unrestrained by the gravitational leash of our sun until now. To see it cross paths with the exact course of an object already known as interstellar is like watching two arrows, loosed from unseen bows, collide in midair. The solar system, by this measure, becomes less a void of randomness and more a crossroads where trajectories are guided by unseen hands. The reaction across observatories and research institutions has been immediate and unrestrained. Telescopes once dedicated to mapping exoplanets or scouring galactic clusters have turned their gaze inward, toward this immense shadow at the solar system's edge. The new object's brightness, muted by the distance, forces instruments to their limits, but already spectrographs hint at compositions unlike those of familiar Kuiper Belt bodies. Its surface reflects light in jagged, uneven rhythms, suggesting cliffs, ridges, and fractures deeper than canyons carved by water on Earth. The presence of metals glimmers faintly in the readings, a trait rare among the icy rocks that haunt the outer regions. This is no simple lump of primordial ice. It is an artifact of forces capable of sculpting on scales larger than planets. The approach toward 3-Eye/Atlas transforms speculation into fevered theorizing. Some envision a natural event, a gravitational shepherding that brought two wanderers into inevitable encounter. Others whisper of structure and design, of intentionality that transcends blind mechanics. The interstellar origin of 3-Eye/Atlas has always raised questions of whether other star systems send fragments into ours. But now, with a 100-fold larger presence drawing itself toward the same path, the conversation changes. What if interstellar bodies do not arrive alone? What if they come in pairs, in fleets, in sequences of increasing magnitude? This would suggest a pattern, one hidden until now beneath the veil of distances too great and timescales too slow for human senses. The scale of implications presses down with weight heavier than the mass of the object itself. Planetary scientists calculate the potential gravitational disruptions this colossus might cause. The Kuiper Belt, long thought to be a static graveyard of icy relics, could be thrown into chaos. Orbits would shift. Frozen worlds might collide, shedding debris that would rain inward toward the giant planets. Even Neptune's measured dance could falter under the tug of something so large, and should the object wander closer, even Jupiter's monumental presence might be stirred, cascading consequences deeper into the solar system's heart. Earth itself, though far removed, cannot ignore the tremors of celestial realignment when bodies of this scale move through the system. What makes the situation extraordinary is the temporal context. Humanity has only just begun to recognize interstellar visitors at all. Oumuamua, 2I/Borisov, and 3I/Atlas were fleeting messengers tiny compared to this Leviathan. To encounter something 100 times larger so soon after these discoveries suggests either a stroke of impossible fortune or a deeper cosmic rhythm, one humanity has only now begun to perceive. It is as though the solar system has been dormant for eons, and now suddenly the gates have opened and the first titans have entered. Beyond physics and orbits, there is the undeniable pull of awe. For those who lift their eyes to the night sky, the knowledge that such a colossal traveler is threading its way toward a meeting with 3I/Atlas ignites imagination. What stories might its surface tell? What origins are inscribed in the metals buried beneath its crust, in the fractures and scars that mar its face? Each discovery about it seems less like the closing of a question and more like the opening of a doorway. This body is not just larger, it is louder, as if the cosmos itself is speaking in a voice that finally carries to our ears. The object's trajectory continues to be refined with every passing observation. Its speed, already immense, carries it along a path that ensures no direct threat to Earth in the immediate sense. But the fact of its arrival unsettles nonetheless. The solar system, once imagined as a relatively quiet corner of the galaxy, is revealing itself as a thoroughfare. Bodies from other stars do not simply pass by at random. They arrive, they interact, and sometimes, as now, they align with uncanny precision. As 3I/Atlas holds its course, faint but steady, this massive arrival looms ever closer to the predicted convergence point. The spectacle promises to be one of cosmic proportions, a meeting of two wanderers under the gaze of countless telescopes and watchful minds. What lies ahead is a mystery still wrapped in distance, but the very anticipation transforms our understanding. We are no longer passive inhabitants of a solar system insulated from the larger galaxy. Instead, we are witnesses to the unfolding of an encounter that could redefine how we see our place in the universe. The immensity of the newcomer is matched only by the immensity of the questions it raises. Is it a solitary fragment of some distant system ejected and adrift until it found us? Or is it part of a procession, the first of many that may follow, each larger or stranger than the last? And if such arrivals can be so massive, how many have passed unseen in ages before telescopes turned outward? The very architecture of the solar system may bear the scars of ancient encounters, long forgotten until this new one arrived to remind us. In the silence of space where no sound carries, the movement of this object still feels like a reverberation. Its shadow falling across our instruments, its looming scale against the backdrop of stars, all of it reminds us that the cosmos is not static, not distant, but alive with motion and convergence. To watch it draw nearer to 3I/Atlas is to stand at the threshold of a revelation, one that humbles human curiosity while feeding it all the same. The hundredfold Leviathan at the edge of the solar system does not announce its purpose, but its presence is enough. It is not merely another rock in the void, it is an arrival, an event, and perhaps a harbinger. Its path toward 3I/Atlas binds two mysteries together into one larger riddle, one that challenges every assumption about the quiet corners of our galactic neighborhood. And as it moves closer, carrying with it the weight of 100 smaller worlds, it transforms the solar system into a stage upon which the universe itself performs a drama of incomprehensible scale. The discovery of an object so incomprehensibly massive, coursing into the solar system with a trajectory aimed toward 3I/Atlas, represents more than just an astronomical curiosity. It reshapes the very boundaries of what humanity has dared to imagine. The universe is not delivering us pebbles anymore, not dust or faint shards of interstellar debris, but something vast enough to redraw maps of gravitational influence. To expand on this requires more than wonder. It requires the full breadth of human curiosity, imagination, and science stretched to their limits. To appreciate the significance of this arrival, it helps to grasp just how unprecedented its size truly is. 100-fold increase in magnitude over what we once thought of as large outer solar system bodies is no minor step. It is a leap that puts the object closer to the category of planetary mass. Consider Pluto, a dwarf planet residing in the Kuiper Belt. This object, larger than any Kuiper Belt occupant we've cataloged, could make Pluto seem like a pebble in comparison. Its radius alone may extend thousands of kilometers, cloaked in a surface of fractured rock and volatile ices locked in silence for billions of years. If mass estimates hold, its gravitational pull could stretch outward to capture smaller companions, meaning it might not have entered alone. A retinue of fragments or secondary bodies could be trailing in its wake, orbiting it like moons or drifting in chaotic paths around its bulk. These possible companions would introduce a secondary level of complexity, as astronomers would have to study not just a single target, but a potential system entering ours. The newcomer might, in effect, be a wandering planetary embryo, a fragment from a shattered star system that survived ejection and traveled untold light years to appear here. Equally astonishing as the scale is the alignment of its path with 3I/Atlas. Astrodynamics is a discipline built on precision, and when calculations revealed that this enormous body was intersecting with the course of an already interstellar traveler, jaws dropped in observatories around the globe. The probability of such a conjunction happening by accident is so minuscule that it invites speculation about orchestrated forces at play. Gravity from neighboring stars could not so precisely guide both bodies into alignment, nor could galactic tides explain the uncanny convergence. Theories blossomed overnight. Perhaps these objects originated from the same stellar system ejected together, separated by millions of years but bound by a common ancestry. Others proposed a deeper resonance, suggesting that interstellar space harbors invisible structures, currents of matter or gravitational corridors, that funnel bodies along unseen highways. If that is the case, the solar system may sit at an intersection of these cosmic routes, a galactic harbor where wanderers inevitably gather. Spectral analysis of light reflected off the new body is yielding tantalizing hints. While faint and difficult to decode, the signals indicate a surface rich in silicate minerals intermixed with metallic elements. Unlike the icy exteriors of comets, this body appears rugged, perhaps even geologically complex. Deep fractures could indicate tectonic stresses, suggesting a history of internal heat or collisions. The presence of metallic reflections has ignited discussions about whether this object could harbor nickel-iron cores akin to differentiated planets. If so, then we are not observing a mere lump of rock, but something with a layered history, a relic of planetary formation on an alien scale. This means the object may contain materials not just rare, but unknown in our solar system. Exotic isotopes, forged in the furnaces of stars unlike our sun, may lie hidden within it. For geochemists and planetary scientists, such a sample would be a time capsule of another corner of the galaxy, untouched by billions of years of solar radiation. The implications for orbital mechanics are profound. If the object passes near enough, it could scatter Kuiper Belt residents like billiard balls struck by a cue. Long frozen bodies may be jolted into eccentric orbits, some thrown inward toward the inner solar system where they could collide with planets or moons. Others might be hurled out entirely, lost to interstellar space. The delicate balance of resonance that Neptune maintains over much of the belt could be unraveled. Even without direct collisions, gravitational stirring of this magnitude could replenish the reservoir of comets that feed into the inner solar system. Earth, though not directly threatened by the newcomer's bulk, may find itself facing centuries of increased cometary activity as displaced objects rain inward. Humanity may be entering a new geological epoch marked not by terrestrial change, but by celestial upheaval triggered from the outside. At the heart of all speculation lies 3I/Atlas, the interstellar visitor whose presence first sparked debate about the nature of galactic debris. Small, fleeting, and enigmatic, it seemed destined to slip back into obscurity as it continued on its way. But this larger body, now following it like a shadow, has forced a reevaluation. Perhaps 3I/Atlas was not alone after all. What if it was a scout, the first visible trace of a larger wave of material arriving from afar? Its faint signal could have masked the fact that it was merely the vanguard. If so, then the solar system is not experiencing an isolated event, but rather the opening chapter of a sequence of arrivals. The largest has now revealed itself, but others may still be inbound, each carrying its own mass, composition, and mysteries. Theories about the origin of this hundredfold giant are as varied as the scientists studying it. One possibility is that it formed in the outskirts of a star system much like ours, only to be ejected by the chaotic gravitational interactions of migrating giant planets. If its original system contained super-Earths or ice giants, their gravitational ballet may have flung this body outward at escape velocity. For millions or billions of years, it would have drifted in the galactic void, frozen and silent until a chance alignment brought it here. Another hypothesis places its origin even further back, at the dawn of the galaxy itself. Perhaps it is a relic of the primordial disk of matter that formed the Milky Way, a survivor of ancient processes that never coalesced into a star. If so, it predates the solar system entirely, carrying within its structure the earliest history of galactic formation. Its collision course with 3I/Atlas may be no more than the universe arranging for us to read two different chapters of that same cosmic story. The encounter is not only an astronomical event, but a philosophical one. Humanity has always viewed the cosmos as vast but indifferent, a stage upon which random wanderers occasionally appear. The alignment of two interstellar objects of such scale challenges that view. It suggests patterns, perhaps even rhythms, that imply the galaxy is not chaos but choreography. This forces a deeper question. Are we observers of a natural dance, or are we witnessing signs of intent on a scale beyond comprehension? Civilizations far older than ours may have existed, risen, and fallen long before Earth cooled. Could these objects be remnants or constructs, dispatched across gulfs of time and space for purposes we cannot yet discern? While speculation of this kind borders on the untestable, it is no less compelling in the face of alignments that defy probability. Telescopes across Earth and in orbit are pushing to their limits to track the behemoth. The James Webb Space Telescope, with its infrared capabilities, is being tasked to probe the thermal signature of the object, hoping to detect faint emissions of trapped heat that could reveal its true size and structure. Radio telescopes, too, are scanning for any sign of emissions, whether natural or otherwise. As data accumulates, supercomputers refine simulations, attempting to predict not just where the object is going, but what its influence will be on everything it passes. There is also talk of missions, though the scale presents challenges beyond current technology. Even robotic probes traveling at record-breaking speeds would take decades to reach the newcomer. Yet the temptation is overwhelming. To intercept such a body, to fly past its surface and glimpse its alien geology, would be a triumph unparalleled in the history of exploration. The very thought electrifies the scientific community, who now look at the skies with a new sense of urgency. The arrival of this colossal object reinforces the idea that the solar system is not isolated. Instead, it is situated along pathways of galactic migration, where bodies from countless stars crisscross in silent procession. Each visitor carries knowledge encoded in its structure. Knowledge of other suns, other planets, other epochs. By studying them, humanity does not just learn about the visitors themselves, but about the galaxy as a whole. This transforms the solar system from a home into a junction. Earth is not merely one planet orbiting one star, but a vantage point at a busy intersection of cosmic traffic. If more arrivals follow, then our understanding of the universe will shift from that of distant observation to active participation in galactic exchange. We will become not just students of the sky, but custodians of a system open to visitors from everywhere. As days turn to weeks, the convergence between the giant and 3I/Atlas grows nearer. Astronomers release updated orbital diagrams daily, each refining the point of closest approach. Public fascination surges as news outlets broadcast animations of the impending meeting. For the first time, humanity feels like it is watching an interstellar drama unfold in real time. This is not distant theory or speculation, it is an event happening now, with consequences that ripple outward into every discipline. Writers, artists, and philosophers seize upon the imagery, the giant bearing down upon the small, becomes a metaphor for forces beyond control. Some see it as a reminder of humility, others as a herald of new beginnings. In classrooms, children sketch the scene with wide eyes, sensing intuitively that this is a moment that will be remembered. The cosmic scale of the event transcends science and seeps into culture, embedding itself into the imagination of an entire generation. For now, we wait. Instruments continue to hum, observatories continue their vigil, and minds around the globe remain fixed on the skies. The newcomer has not yet revealed its final secrets, nor has its meeting with 3I/Atlas reached culmination. But the anticipation alone has altered our relationship with the universe. We no longer see ourselves as isolated in a quiet neighborhood. We see instead that the galaxy is alive with motion, and that our solar system is part of that motion. The hundredfold giant, silent and unyielding, carries with it the weight of countless questions. Whether natural relic or something more, whether solitary or the first of many, it has already achieved one thing beyond dispute. It has expanded the horizon of human thought. The solar system is larger now, more connected, more alive than it was before its arrival. And as it moves inexorably closer to 3I/Atlas, humanity watches, listens, and wonders what the cosmos will reveal next. The sheer arrival of a hundredfold larger object aimed toward 3I/Atlas has already shaken the intellectual ground beneath astronomy. But the event also carries consequences for disciplines far beyond astrophysics. The implications stretch into technology, culture, philosophy, and even humanity's vision of its own destiny. To extend deeper, one must trace how such a phenomenon ripples outward into new frontiers of thought and action, uncovering facets that may not have been considered in the immediate rush of scientific observation. Encounters of this magnitude often inspire leaps in technology. Just as Sputnik spurred the space race, the discovery of a supermassive incoming body is igniting discussions of engineering marvels previously confined to speculative papers. The immediate question is how humanity could physically reach such an object. Its distance is colossal, but the motivation is even larger. Current propulsion methods, chemical rockets, or even ion thrusters seem laughably insufficient when set against the urgency of intercepting something so unique. This has sparked renewed investment into experimental drives. Concepts like nuclear thermal propulsion, fusion-based drives, and even solar sails are being revisited with greater seriousness. The possibility of slingshot maneuvers using the giant planets is under consideration as a way to propel probes outward with unprecedented velocity. What once seemed like distant science fiction now becomes pressing necessity. Some engineers are sketching missions not just for flybys but for orbital insertion. If the object is truly of planetary scale, a probe could use its gravitational well for braking maneuvers, anchoring robotic landers onto its fractured cliffs. Drilling into its crust and sampling alien metals are no longer idle dreams. These challenges require technological revolutions in autonomous robotics, radiation shielding, and communication over vast distances. The event, in essence, serves as a forcing function to accelerate spacefaring capability by decades. The cultural impact of a colossal visitor cannot be underestimated. Human societies have always been shaped by the stories they tell about the sky, from myths of constellations to the age of telescopic discovery. The appearance of a hundredfold Leviathan converging with 3I/Atlas is an event destined to leave a permanent mark on human culture. Artistic communities are responding with intensity. Painters depict the cosmic drama as if it were a celestial duel, while sculptors carve representations of the giant as mythic titans. Writers weave narratives where the universe itself seems to be speaking, and musicians compose symphonies inspired by the gravitational rhythms of converging bodies. It is not merely science that responds, but imagination itself, creating new myths for a modern age. Religious and spiritual traditions, too, find themselves stirred. For some, the alignment of interstellar travelers speaks of divine orchestration, a cosmic sign woven into the heavens. For others, it becomes a parable of impermanence, a reminder of how even celestial structures can shift under forces beyond comprehension. Pilgrimages to observatories increase as people seek to glimpse the phenomenon with their own eyes. The skies have once again become a canvas for meaning. Beyond awe and speculation arises a question of ethics. Humanity has never faced an object of this magnitude from outside its own system. Should such an arrival be regarded purely as an opportunity for study, or does it demand a form of reverence, even caution? Philosophers of science are already debating whether sending probes could inadvertently alter the natural state of such a body. The very act of drilling into its crust or depositing instruments may constitute interference on a scale unexamined before. This raises the question of stewardship. If interstellar visitors are carriers of knowledge, perhaps even life's precursors, do we have a moral duty to preserve them, untouched? Or does the potential gain of understanding outweigh such concerns? The collision of curiosity and caution has never been sharper. Some argue for a planetary protection framework extended not just to worlds, but to interstellar wanderers themselves, while others urge boldness, warning that hesitation could mean missing a once-in-history chance. The magnitude of the discovery ensures that no single nation or agency can monopolize it. Just as the International Space Station became a symbol of cooperative endeavor, so too might the mission to study the giant visitor become the defining collaboration of the century. Already, agencies from multiple countries are pooling data, sharing telescope time, and aligning computational models. The object transcends borders. It belongs to all humanity in the sense that it reshapes the destiny of the entire species. This cooperative spirit could spill over into broader arenas. Rivalries may be softened under the shared awe of a cosmic visitor. Resources once earmarked for competition may be redirected toward collaboration. If humanity's first true encounter with an object of planetary mass from interstellar space becomes a cooperative venture, it may inaugurate a new era of global unity centered not on terrestrial concerns, but on cosmic exploration. One of the more subtle consequences of such a discovery is psychological. Humanity has long considered the solar system as the natural boundary of its neighborhood. To see not one but two interstellar travelers converging challenges that boundary. The solar system is no longer an isolated bubble but an open doorway. This realization expands the definition of home. Earth is still our cradle, the solar system our environment, but now the galaxy itself feels nearer. If objects of such immensity can arrive here, then the distinction between our system and the rest of the galaxy becomes porous. The cosmos ceases to be abstract. It becomes part of our lived reality. Children growing up under this sky may take for granted that visitors arrive from other stars. Their sense of scale will stretch beyond planetary horizons to interstellar ones. In practical terms, this discovery could seed the blueprint for humanity's next great chapter. Once the giant's arrival is studied, missions may be planned not just to it, but to future interstellar visitors. Networks of telescopes may be designed specifically to detect such wanderers earlier, giving time to prepare intercept missions. Technology tested in pursuit of this Leviathan could become the foundation for voyages to other stars. Some thinkers even suggest that the object itself could become a vessel for exploration. Its mass and structure might allow it to serve as a platform for human settlement or as a natural shield against cosmic radiation. If tethered with technology, it could be transformed into a moving observatory, a bridge between systems. Such ideas, while ambitious, highlight how the discovery shifts exploration from the theoretical to the tangible. One of the most provocative aspects of the encounter is the silence of the newcomer. Its scale and trajectory invite speculation about intelligence, but so far it has emitted no signals. Radio silence may simply mean it is inert rock, but it may also mean we do not yet understand how to listen. Scientists are broadening the range of detection methods, scanning not just traditional radio bands, but infrared and even gravitational wave signatures for anomalies. The possibility that such an object could be engineered or at least influenced by intelligence cannot be dismissed outright. Its targeting of 3I/Atlas remains a statistical oddity too great to ignore. Some propose it could be a form of galactic communication not intended for us at all, a message sent between systems, with our solar system merely lying in the path. If that is the case, then we are eavesdroppers on a dialogue older than our species. The silence of the object may not be absence of voice but presence of a language we cannot yet comprehend. For the scientific community, the discovery represents a renaissance. Entire branches of study are being revitalized. Planetary dynamics now considers influences from beyond the solar system. Geochemistry anticipates isotopes never before cataloged. Astrobiology wonders whether organic compounds could be preserved within such a body, carrying the seeds of life across the galaxy. Even cosmology, concerned with the large-scale structure of the universe, takes interest in whether these interstellar leviathans trace the hidden filaments of galactic matter. The event forces integration of disciplines. Astronomers, geologists, chemists, physicists, philosophers, and even theologians are drawn into shared dialogue. The object becomes a nexus of inquiry, dissolving traditional academic boundaries. It is no longer enough to specialize. To understand the newcomer requires synthesis. This collaborative spirit, if sustained, could transform the structure of scientific research itself. Perhaps the most profound consequence of all is how the discovery reshapes humanity's place in the universe. For centuries, we have swung between two visions, a cosmos indifferent to us and a cosmos ordered around us. The arrival of a 100-fold larger object aimed toward 3I/Atlas suggests a third path. The universe is neither chaotic nor centered on us. It is interconnected, dynamic, alive with convergences. We find ourselves as participants in this cosmic choreography. Our solar system is no longer an isolated island, but part of a grand current of motion. Our role is not to dominate, but to witness, to learn, and perhaps to join the flow. This realization carries humility, but also empowerment. To see ourselves as part of a larger rhythm is to see possibility where once we saw only isolation. If you like this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on a 100x bigger object entering our solar system? We want to hear from you. Thank you for watching, and see you next time.